All right, everyone, welcome to another episode of the TWiML AI podcast. I am, of course, your host, Sam Charrington, and today I'm joined by Mike Del Balso, co-founder and CEO of Tecton. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Mike, welcome back to the podcast.
Thank you for having me. It's great to be here. I'm excited for the conversation today.
I am as well. It's been a while since we spoke. I think the most recent time was about a year and a half ago. We were talking about feature stores for ML ops. I suspect that topic will come up again, but let's dig in. I'm looking forward to talking about what you've been up to, the idea of feature platforms, and of course the intersection with all that and data-centric AI. For those who haven't heard any of our interviews or don't know your background, why don't you share a little bit about how you came to work in ML?
I first got involved in machine learning. I was a product manager at Google and dating myself now, but back in like 2013, I joined the ads team at Google. And, as you know, Google uses a lot of machine learning to determine which ads to show people. And this is before machine learning was super cool and stuff like that. I don't even think we used the word machine learning at the time, but we had a lot of models in production that were doing some real time decision making around, who is this person? What kind of interests do they have? Which ad is most relevant to show to them? And the team was really excellent at what we did not, at a term we didn't have at the time, which was ML ops. So there's a lot of ML ops that we were doing at that time, production machine learning. That was kind of like, I think of that as kind of like phase one of how I got involved in machine learning. After that, I actually joined Uber in the kind of early data ML days of Uber at a time when there wasn't a lot of there was very little machine learning happening in production at Uber, and it was kind of the task for me to start the ML team and help us figure out like what to do with all of this data. We had all this data at Uber. How do we help Uber make a lot of excellent automated and smart decisions and experiences in the product? And so we built the ML platform team at Uber, and we made a platform called Michelangelo, which was really exciting. We can talk about that, of course. And in the process of doing that, we developed a lot of cool patterns. Really spent a lot of time on developing a lot of ML ops workflows and different pieces of infrastructure. One of which is the feature store, and that is a really big inspiration and a really big kind of like theme of Tecton that I'm working on today.
When I think back to Michelangelo and that blog post that got so many of us excited about what you were doing there at Uber, and the state of play at the time, like compared to now, we've built out a lot of the stack for ML ops now, or at least we've got contenders for various pieces. But when you left Uber to start Tecton, the field was pretty wide open. Why'd you start with a feature store? I mean, you had all the pieces, right?
That really good question. I think we have to like think back to that time and think about a very different time where, if you look today at the like what are all the ML ops tools in the industry, the map of the industry, there's 4,000 ML ops companies, and like what plugs into what and how do I choose what it's crazy. At that time, it felt like there was a lot of stuff, but there actually wasn't a lot of stuff relative to today, right? But it always feels complicated, and a lot of the terms, there wasn't the same level of specialization and stuff like that. So back at when we started Michelangelo, we started it in 2015. So it's a very different kind of generation of ML tooling and ML techniques and stuff like that. Back at that time, the thinking was an end-to-end ML platform. Let's just build a solid experience for. It was all about democratizing ML. How do we make it possible for a data scientist to do machine learning? It was kind of like enabling them to do it for the first time. And so we built an end-to-end platform that that enabled them to choose their label, choose their features in a web UI, and get their model built in a web UI, manage it in a web UI, all the way to deploy it into production. It was revolutionary at the time. It was something that really enabled people to go from 0 to 1, and it handled the the full workflow. The industry was moving from this a general idea, the dream of having the the one size fits all platform that will enable all of the people within the organization, really democratize everything, to the kind of point where people are disillusioned with that dream and they really realize, hey, you know what we need is a bunch of reusable components, because there's not a one size fits all one system. There's a bunch of reusable components that we can piece together to form the ML application that I'm trying to build. So it'll have the right kind of serving system for me, and I can plug into the training system that's relevant for me. And so we actually did that. We brought Michelangelo through that journey as well, from being a monolithic system to more of like a collection of best practice components that are compatible and fit together quite well. And so in that, going through that journey, and building Michelangelo in the first place, we were really focused on how do we help people get not a model built, not like showing some results in AUC curve to their team, but how do we, help the fraud team, help the ETA team at Uber, all these different teams, help them actually get into production and get value. They were use case teams. They were trying to get something done. They didn't really care about like, cool, I've trained some models and they're not plugged into the product. And so we thought about it as they're building an ML application. And so this is super related to the concept of data-centric AI. What's part of an ML application? Well, of course, you got to build your models and manage your models. And then secondly, there's a variety of data pipelines that are also part of that ML application. The things that generate the data that your model consumes or your training system consumes to generate a model, or the data pipelines that your model in production uses to generate inference in real time. All kinds of data pipelines happening there. And so we realized, hey, in the Michelangelo system, we really built a lot of model management stuff, but what we spent most of our time building is a bunch of data management stuff. And that's actually what we called the feature store. And so it was a lot of kind of centralized and automated data engineering that we found that we were doing again and again across all these different use cases. And we brought that together into this one layer in the Michelangelo system and became a kind of its own component. We called it the feature store. We found that it was one of the most impactful systems to help someone go from 0 to 1 to get into production quickly, and to be able to reuse machine learning across these components across different use cases, to share and to help reduce the incremental cost of creating the next machine learning model. And so reflecting on that at the time, we thought we glimpsed the future. We realized it's really about the data, the feature store, the concept of the feature store, and later the feature platform is really the kind of the data layer for machine learning. And that's what got us so excited after publishing a blog post, and everybody had like all kinds of extremely positive feedback around that. Hey, I'm trying to build something like that. Can you guys come work for us, kind of thing. There's a lot of attention there, and that made it clear to us that this is a design that's here to stay, and this is a design where, or this is a pattern that there should be a proper enterprise solution built around. And so that motivated us to create Tecton. Tecton is an enterprise feature platform, and we help teams who are putting machine learning in production manage their data flows for their ML application through all stages of the ML lifecycle.
You referenced the complexity of data infrastructure when you were building Michelangelo. Speak a little bit to how you've seen that evolve over the past 5 years. Has it been relatively static? Has it changed significantly? A little of both?
I think we have seen some things change quite a bit. Some things change a lot less than I would have liked. I think one of the biggest changes in our journey, and the journey for many companies, is frankly going from having a lot of data on-prem in a Hadoop cluster, 5 years ago, to now I'm using a cloud data platform and all my data is on a hyperscaler cloud provider, right? So what does that mean for a data team and an ML team? What does it mean for a data team? It means you're not managing a bunch of Hadoop clusters. You don't need a 30-person data infrastructure team to manage basic how do I store my data and keep it up and running. Like for example, when I joined Uber, there was just outages, like the data wasn't available. Like the whole Uber app would go down all the time because there was just issues with maintaining all of the data systems. Now, a lot of those basic data capabilities are largely resolved. You put your data on the cloud, you adopt a data lakehouse or a data warehouse, put your data in, for example, Snowflake or Databricks. They're great solutions, and you're going to get really good performance, great reliability, and it's going to be likely at a price point that works for your team. It's going to be cheaper than maintaining your own team to build all of this stuff. And then it's interesting to reflect on, like, what does that mean for a machine learning team? Because machine learning teams previously in that previous world were building custom connectors to the custom data systems that existed in their businesses. How do I connect to our weird file format? And the lack of reliability. Yeah, I mean, the ML teams would be constrained by the data choices of the underlying data platform team that they depended on, and that would come with a lot of constraints. At Uber, we were super fortunate because we had a super legit data platform team that did a lot of stuff. We had real time data, really high quality streaming data, and an excellent kind of like batch data system, a gigantic Hadoop cluster. But that's not something that everyone was uh, so fortunate to have. And in moving to the cloud, you kind of get all of this stuff now very easily accessible, often serverless, and it makes for and then I think that has a really big impact on the machine learning space or any consumer of data tool of underlying data systems, because now there's standardization. I'm a machine learning team in company A. I build a connector to Snowflake and some cool thing that plugs into Snowflake, and I can build models with it. Well, I can share it with company B, and now they can use my machine learning tool that was built for that underlying data system because we share the same underlying data system. And so there's a lot of commonality at this foundation layer that allows people to share at the ML layer, share things that they've built and have them be reusable across teams. And so it's really increased the pace of innovation there.
And thinking about data lakehouse, data warehouse, those are more about static data, so to speak. Relative to streaming. Has streaming matured as much or to the same degree?
Streaming has matured a bunch, but there's still a long way to go, honestly. And we find that a lot of our customers are still struggling with it. And frankly, part of the value proposition of the feature platform that we build at Tecton is it makes a lot of this stuff just a lot easier. So how streaming used to be, you needed to have a whole team spin up a Kafka deployment for you and maintain a Kafka cluster. Now there's really good cloud solutions. There's Confluent has Confluent Cloud, so it's much simpler with Confluent Cloud nowadays. There's a variety of other online streaming solutions that make things much simpler, but we're finding that ML teams are still struggling to use them. So, for example, a machine learning team is predicting fraud at a big bank. They want to find a way to say, hey, if this user has sent more than 100 transactions in the past 5 minutes, let's not allow any other transactions because it's likely that it's going to be fraud, right? Well, what do they need to do to get there? And they want to do this at scale for a lot of different users. They need to run a lot of this streaming infrastructure, and they need to be running stream processing to aggregate over all of those transaction events, turn them into feature aggregations, and then plug that into their model, and then not just set this up once, but staff up a team to ensure that these systems don't go down, they don't go out of memory. If it goes down, that they're retried, that they're available and high availability and debuggable, and someone's on call for it. That's the productionization side of streaming. That's still pretty tough, and we find that um, a lot of teams that are trying to build interactive machine learning driven experiences. You want your recommendations on your website to react to what the customer was just clicking on. You want your fraud detection system to take into account like what the person's actions were just were on this account. That kind of stuff, productionizing it relies very frequently on streaming. It's pretty hard to do today, and it's one of the things that actually we've built a lot of IP in making a lot simpler for ML teams. All these real time ML capabilities are an area where there's a lot of innovation happening right now.
And so I think it is clear based on that that what you're seeing with regards to feature platforms isn't about replacing all of this infrastructure that we've only recently standardized,
Right.
but rather it hooks into them.
Well, let's just talk about like what a feature platform is, and then we'll talk about kind of like how it can connect to your systems and what does it do? Does it replace your existing systems or not? And and so when we work with teams who are trying to put machine learning into production, what they have to do is not just build a model and put a model into production, but they need to stand up, they need to develop, productionize, and operate data flows, feature pipelines that are constantly computing the up-to-date, very fresh feature signals that are going to be available, are going to be used for real-time inference. So we just gave the example of real-time fraud, where I'm doing some aggregations um, over some like recent web events. Let's say it may be a search use case, and so a very different type of data path. The data may come from like a query, like a search box that someone typed a query into. So it's more like a real-time signal that comes in from the end user application. And some signals, they're just pre-computed. Like, is this person in a banned country? Well, we can pre-compute that, and we can just make that ready to serve right when we want to make that prediction. There's a lot of data engineering that goes into each type of these features. People trip up in a lot of different uh, uh, types of data challenges that comes up with them. For example, consistency between that data um, at inference time compared to consistency with that data at training time. So you want that data to be the same. When you generate a training data set, you need to go back in history for all of that data. So you need to have all of that data logged so you can generate historical training examples. You need to monitor this data to make sure it is serving at the right operationally, serving at the right speed, it's staying real time, it's fresh, it's available. But also you want to make sure that it's accurate, it's the data quality is high. And then there's a variety of data infrastructure that you end up having to spin up and support in production. For example, systems to serve this data at scale, systems to operate to do the stream processing to generate your features. So we think about it as transforming your raw data into features, storing that data both for training and for inference, serving that data for inference in real time, monitoring the data, and building an excellent developer workflow for ML ops and for the engineers to fit it into their DevOps processes. These are all within the scope of the feature platform. And the reason why there's so many things here is because there's just like a lot of challenges that you need to solve before you can actually credibly claim that your model is running in production in a reliable enough way that you're comfortable depending your revenue on it. You want to actually depend your product on it, type of thing. And so we've built a platform to make all of those data challenges much simpler. And so how do we do this though? Well, we are not delivering a completely new data and ML stack to the ML user, to our customer, right? We are plugging into the data sets that the data infrastructure that they have. So, people come to us and they say, "Hey, I have Snowflake, and I have Databricks, and I have a Redis cluster," and we'll say, "That's great. We will actually orchestrate those systems. So we'll orchestrate transformations on both of those. We'll plug into those, take data out of them. We'll load it up into Redis. Will maintain an online serving layer for your model. So the interfaces here are we plug into raw data and we serve that data to the model that's in production or the training system that's building the model. But under the hood, we're not implementing all of those different uh, data processes from scratch and running all of that infrastructure in our domain. We're actually orchestrating the best in class cloud data infrastructure that your team is already running within your own stack. So we're a lot more of an orchestration layer for like a data orchestration layer for machine learning than anything else.
To relate this a bit back to this idea of data centric AI, you mentioned before we started recording the interview as we were chatting this idea about a ML flywheel that kind of reiterated the importance of data uh, for ML. Can you talk a little bit about that idea?
For sure. One thing that I think is really nice about data centric ML is it's a theme that comes along with it is declarative interfaces, and um, and maybe some of the other folks that you've been speaking to in recent episodes have been talking about this as well. But this is one of the key things that we have really focused on. We don't have our users say, hey, plug this infrastructure into this infrastructure, run this operation, retry it if it doesn't work, and then plug it in here and then run it at this frequency. We just have the person say, this is my feature. It should be this is the feature transformation. You take care of everything. I need it to be in production. And the Tecton system handles a lot of things behind the scenes to make that happen. Earlier on in the conversation, I mentioned like at Michelangelo, one of the things that made us really successful was we were focused on the end-to-end machine learning application. We weren't just focused on helping someone train a model or manage models. It was, hey, what's the whole series of workflows that you have to go through to actually have an application that's both reliable and accurate and making repeated predictions. And so it's like a live production application that you're operating. And so there's a couple of steps to that we see that the best teams are doing when they're building their production ML applications. And we can walk through these steps, right? First, you got to build the training data set. So where does that training data set come from? Well, it comes from your company's underlying data sets that are modeled data sets that are kind of shared across the business, wherever your company's data is. That data is typically like a bunch of logs of user events that come from your product. So there's just kind of this data loop that we found our customers building, right? You make some prediction, and so maybe you're predicting like, is someone going to click on this product or not? And then based on if they click on that product or not, you log that data. That's going to become future ground truth, a future label. You may join that data together with other labels that you've logged, and so you have um, like now a joined label data set, and maybe you log some features, so you have a feature data set as well, feature logs. And then you may assemble these data sets into a training data set. And so now you want to take all that data and you want to build a model. So now you've built a model, and then you want to use that model. And so there's a variety of other data sets that you're building at that time in real time inference type of workflows where you're maybe generating some candidates and then generating some features for each of those candidates, and then you want to score those candidates, and you ultimately are making a prediction, and you're delivering that back to the product, to the user, to the customer, right? So there's this kind of data loop of like, collect some data, organize it, learn from it, and decide. And then based on, and make a prediction. And then based on that, collecting again, organizing, and we want this data goes around in this loop. And what we've seen is that the best ML teams, the teams across the industry that are the most successful at machine learning, are really, really good at managing that loop and building that loop. They're really, really good at getting that flywheel to really be running. The more every iteration of that flywheel, you're collecting more data, you're training your model's getting better, you're making better predictions. And so there's a variety of things that help people become. There's a variety of like good things about that come out of being excellent at at that flywheel, you have really clear ownership of who runs each part of that flywheel, and it's easier to make changes. Everything's more debuggable and more easily monitored, and just small changes feel like small changes, and ML just feels natural and easy. If your ML flywheel, you don't really have it working well, maybe you don't know, hey, who's actually the person that like logs data from the application into like the data warehouse, because now I want to add a new feature to my model, but I got to go find that person so they can log some data for me. In that world, every small change you want to make, it ends up becoming like a big thing. Like either you don't know who runs this system, and then it's broken. You got to go debug it you got to go find the person, kind of thing. And so ML becomes really hard. Models don't update as often. You tend to see those teams. A symptom of those teams is they're still stuck in version 1 as the model that's in production. And so the machine learning, the teams that are really good at ML, they've really focused on building and managing this ML flywheel. And it's my claim that great ML applications require a great ML flywheel. And so I was talking about the declarative definitions there. That fits into this whole thing, because it's really tough to. There's a lot of parts, a lot of different technology all throughout the ML flywheel, and so I think it's going to be really important. We're talking about data-centric AI now. It's the declarative definitions patterns that are central to data-centric AI. That's going to be applied. I think applying those to the whole ML flywheel is going to be a big unlock. It's going to make things a lot easier for teams to really build and maintain their whole ML flywheel, because it manages and it hides away a lot of the complexity of all of the different technologies that span from the analytic world to the production world, from the forward pass of the data, learning and making predictions, to the bringing the data back into the analytic side of logging and organizing the data. It's a lot of stuff, and teams need some much simpler interfaces to define these things. And I think these declarative interfaces are really the key to unlocking the ability to manage the ML flywheel for the average team.
In a lot of ways, the promise of ML ops was giving teams a platform technology for managing this flywheel, or even more strongly, creating a flywheel where before there was kind of bespoke one-off transitions and handoffs from one team to the next. And part of that idea was like applying some of popular ideas like DevOps and continuous delivery from software engineering to ML. Uh, Has that, how have you seen that evolve? Do you think that has played out the way, folks have wanted to, or where do you still see gaps?
So one kind of symptom that things are not as they should be is that we talked about the ML ops landscape. There's like 4,000 different things there, and it's just inherent. Even if you know the space really well, like you do, it's still like, whoa, there's a lot of things here. And an average ML team, firstly, realistically, the average ML team is not expert at all of those different things. But secondly, they have to piece together a lot of these different items and kind of duct tape them all together into like a coherent application that runs smoothly. And I think there's been a variety of ML ops efforts to make that process smoother. What we've seen is people have gotten it wrong in two different ways. One way is their scope was too small. So there's a variety of systems that focus only on a subset of that whole flywheel, right? So they may just focus on, let me make the process of training a model really good. Like I'm going to do some, experiment management just in the learning phase, for example. Or let me just, I'm a tool to help, do some prediction inference stuff better, but it doesn't really address the whole flywheel part of it. And then the other way in which a variety of tools just have not been successful is I think they just bit off too much more than they can chew, and so they got a little bit too ambitious, and they said, "Well, we're the system that will do everything for you," and so they really set their scope on the whole ML flywheel, even if they weren't, actively consciously talking about like that bottom half of that flywheel that brings the data back into your from production back into your training data sets. But it's just the dream of like, we handle everything, just use our tool and everything will be so much easier for you.
Yeah, I love that you bring up both those points because I've written about this previously in
Oh
this
yeah, okay.
definitive guide to ML platforms ebook and called it this wide versus deep paradox. Like,
Yeah.
you have, just as you said, a bunch of tools that are trying to, solve the end-to-end platform, but don't have sufficient depth in any particular area. And then you have others that are, they only do one thing, but then, they don't necessarily integrate the pieces together. And it's a tough spot. And I think that's a part of that, just state of play is what's led to the rise of platform teams that are forming to kind of have been forming to pull all the pieces together and try to ensure an end-to-end experience, if not based on end-to-end tools.
That's a really good point. That does speak to the need for platform teams, and that helps and platform teams justify their existence with that. To finish up on like in which ways the very broad folks get it wrong. I think we're still evolving as an industry. The best patterns are still emerging here, but I think what we're seeing is those folks that promise everything. It's just a really hard problem, and there's a lot of things to get right. And realistically, if your product is, we're going to get every single thing right, that's unrealistic. And customers, average ML teams, they don't want to get stuck building they don't want to get stuck with an inflexible ML platform that only lets them do certain things. And so, what we're our approach with the ML flywheel is not to say we do everything. Our scope is the whole ML flywheel, but we're really focused on managing the data sets and enabling the data flows through that ML flywheel. So we're focused on helping you create your feature logs, create your training data sets, create your, calculate your features in real time, have a unified data model across this whole ML flywheel, and generate compatible schemas and all of the different pieces of infrastructure, and manage as much of the data engineering through that as possible. So we're taking a really big chunk of all of the work that needs to get done, but there's a lot of stuff that we're not doing. We don't touch models. We don't build models. We're not the model management system. And so we think that that's a much more manageable domain that's very valuable, that we can really focus on the workflows. We can really focus on improving those workflows and making an amazing user experience there. So that's our approach, and how we really see us doing something different than the whole end-to-end ML platforms that take on too much, and the very specialized tools that only solve one part of the workflow.
And so you brought us back to this flywheel part of the discussion, but I know you've got a interesting take on platforms teams as well.
Yeah, I mean,
What are you seeing there?
well, on the platform teams, we were just talking about like how a lot of these challenges allow ML platform teams to justify their existence. And so if you can kind of think of both of those domains, right? If they're either piecing together a bunch of small things together, and they're really running a bunch of glue code and building kind of like a brittle infrastructure within the company, or they may not want to take on that type of challenge. And then what the platform team is about evaluating different um, end-to-end platforms, ML end-to-end ML platforms, and just choosing the right one and operating that within the business. And there's different failure modes for both of those technically. So there's it's really hard to maintain your glue code and your duct tape and keep everything running in a reliable way on the first one. On the second one, you're fundamentally signing up. You're putting all your eggs in one basket, and you're investing in a system that inherently is going to be have the flexibility of just a single system. And as soon as your business's needs outgrow that, then it's it's going to be on you to solve that. And that's even a much harder position to be in, because then you have to expand from a single platform that you have within your business to building a whole stack from scratch. And so that's a little bit on the technical side. But I think I have to say that I haven't seen ML platform teams be very successful in industry generally. And this is a little bit of it's not something that like ML platform teams necessarily want to hear, but we work with a lot of ML platform teams and a lot of ML use case teams. And so the use case teams are the folks who are building the recommender system to power the website, or they're building the fraud detection system to block certain transactions, stuff like that. They have a very specific business impact that they're measuring their success on, and they're under the gun. They're trying to get this stuff going and launched as soon as possible, and they're working with business people, and it's a team of data scientists, engineers, all mixed together, and the product engineers as well. The platform teams are really focused on, hey, let me kind of like centralize a lot of our engineering investments that the use case teams are making, and bring a lot of that engineering into one place and build some reusable components to better enable those use case teams. And so that's great, and that's actually is a really good model. The challenge that we have, and that we see a lot of like mistakes that we see a lot of companies making, is it's not uncommon to see a platform team exist before the use case teams exist. And that's a problem, because what is the platform team trying to do if there's no use cases? You got to start with the use case. You have to have concrete business outcomes that you're trying to drive with machine learning. And then only then, once you understand those requirements, does it make sense to build a platform team, and when you have multiple of those use case teams, so you can support them. One thing that a really good sign that a platform team is struggling and is not set up for success is when they don't have requirements. When you talk to them and you say, so what exactly are you trying to build? Like kind of what kind of scale do you need? What kind of latencies do you need? Like, what do you need? And they don't know. And when they don't know, it's because they don't have use cases yet. And then and they also don't have a clear decision-making process as well, because when there's not concrete business um, use case tied to it, it's kind of like building for the future. It's all speculative. Who should make this decision? And we see those teams struggle, and they spin their wheels a lot because they don't really have like a concrete direction that they're going towards. And so I would recommend that any ML, if you're on an ML platform team, think really carefully about who your internal customers are, what those use case teams are, because the ML platform is a product, just like any other company is building a product. And the most like the best advice for anybody building a product is to focus on your customers. And if you don't know who your customers are as an ML platform team, it's really hard to find success.
No, that's awesome. It prompts me to plug our Tuimocon event, because we've spent a lot of time trying to help platform teams understand what the best teams in the industry are doing. And we've got this event coming up in the fall, but also we just revamped our website, and all of the content from the past two conferences is up there. And I'm thinking of a couple in particular that have talked a lot about this kind of thing. We've been doing these team teardowns where we talk about how the platform teams engage with the user teams, and why those interaction modes are so important, as well as thinking about an interview that I did with Fran Bell, who ran a platform team in Uber that was focused on forecasting and kind of higher level platform functionality, and really interesting. Their approach was to, these teams were off doing what they were doing, these use case teams that you were describing, and they would kind of talk to all these teams and identify the things that the wheel that everyone was reinventing, and kind of build a platform around that kind of functionality. So lots of great insights there from folks that have been doing it.
And you mentioned Fran Bell. I worked with Fran at Uber, and that platform was very successful that she built. And the approach that they had was not, hey, you know what would be cool? Let's build a time series forecasting platform. It was definitely not that. It was we have a bunch of time series forecasting problems that we're solving, and they went and built them. And then they had the 3, 4, and then it became 10 different teams that were doing the same thing. They were like, you know what? Why don't we just build, a thin layer that these different teams can reuse? And then they kind of just added more automation into this layer and centralized more and more into it over time. And as they were able to bring in the different use cases, the requirements from the different use cases. They had a purview that individual use cases didn't have, and they were able to think more creatively and more innovatively about how to solve this stuff. And that's a layer where they made some really amazing inventions, and that works both at the kind of like platform team looking at the use case team direction, but it also works at the platform team looking upstream at other infrastructure dimension, because they were able to build on top of the Michelangelo system. And so we actually integrated those systems over time. And so all the time series the time series stuff that the time series platform was building was actually, compiled down to Michelangelo jobs and Michelangelo model training and model serving types of things. And that was like an excellent example of like a great value added by a platform team. But none of that would have been possible if Fran's original attitude was not to just solve the problem. Like, just get your first time series thing solved, and then you can figure out how to do some cool platform thing later on.
Yeah, yeah. And I'll link to that particular interview in the show notes for folks that want to, for folks who this problem of how to build a successful platform team resonates. You said something else in our kind of pre-live chat that I thought was interesting, around kind of what really matters, when trying to when trying to do machine learning.
What matters ultimately is creating business value. And so it's either helping your company have more revenue, reducing the costs, adding or reducing risks. And so, we talked about ways in which platform teams, things go wrong for them, but there's also individual ML projects rather, that that trip up in a variety of different ways. And I think the biggest theme that I see is focusing on problems that are just not that important to the business. And I saw this a bunch of times at Uber. A data science team, in some corner, there's three people spending a lot of time solving this problem that's, it's an interesting machine learning problem. It's really cool technology. It's fun to work on, but it takes some, of course, just like any project, it takes some engineering investment. It takes any type of different, like, cross team collaboration to actually get this thing across the finish line and into production when you want to deploy it into production. And um, that requires someone up the chain, some executive, to say, yeah, we should spend engineers on this. This is important enough that we should staff a team against this. And often that doesn't happen. And why? Because the problem is just, it's a small thing. Who cares? We didn't really need to. It wasn't that important for us, that random problem that you chose. And so I think this is like a really um, uh, important thing for like ML practitioners to think about. And I've seen it again and again have big impact on people's careers. The ability to choose the important problems. You have at your company, there's so many different cool things you can apply machine learning to, but how do you choose the ones that are most important to the business, that are going to have the biggest impact at the end of the day? I think that really requires understanding what matters to the business. What are the company's goals? What metrics are they trying to move? And then which levers do I have from my position to help me have some impact there, and not think about it like as a technology first. What's a cool problem? I heard about this cool technique. Let me apply it to this problem, type of thing. That's where a lot of teams on the use case side of things, not the platform teams, get things wrong.
As you're talking to use case teams and platform teams, you've identified a bunch of the pitfalls that you see them falling into. How do you characterize the different teams that you speak in terms of their level of maturity and how effective they are at sidestepping these traps?
I think a lot of there are a variety of different ways to kind of plot out a like steps of maturity. And one of the things that we think about a lot is as a sign of being at a minimal level of maturity for us to really care about working with those people, or to feel like they're mature enough that we should work with them, is Do they have one model in production? That's a really good sign of the health of your ML team, because if you can't get one model in production, what is it? It may not be. The problem is it may not be a machine learning thing. It may be you may not have executive buy-in. You may be working on the wrong problem. Maybe nobody in your company cares about that problem, and so no one's helping you get to production. Maybe you don't have the right underlying data infrastructure. Maybe the engineering team just sucks, and so you're just not. There's all these possible things, and so you could be super skilled at machine learning, but then there's all of these other things that are holding your team back. And so we de-risk that by only working with people who have one model in production. And that's a sense of that gives us a sense of not your ML maturity actually, but all of the rest of the maturity. Do you have your data in the right place and stuff like that? You had the right competence to get past the finish line once at least. And then what we can help you with is help you make that process a positive ROI, make that process valuable for you, make it repeatable, make it reliable, all of that kind of stuff. But there's some kind of like core foundational things that teams need to get right first. And I think, but I think in terms of different types of ML use cases. Some teams are focused on operational machine learning and they care about real time ML. You can imagine a different maturity curve and kind of milestones for a team to get there than than a similar maturity curve that would apply to like a team that is doing offline repeated like document analysis or something like that. So I don't think there's a general maturity curve that applies to every team, but it's more like on a per use case basis of like what is your role in the interaction there, and then how can you find the milestones that matter to you, and then that example of getting past the finish line once is one important one.
It strikes me that one model in production, yeah, that seems like a really low bar for 2022.
Yeah, and you'd be surprised how many teams are still working on that. And it's not that wow. Like machine learning is really hard there, but it's the types of problems are, hey, our data is still on prem, and our data science team started on AWS, and so they can kind of like pull in data into the cloud, but like, is the data productionized into the cloud? Are we going to run the ML application in the cloud? Are we going to bring the ML application back to our data center? We're still figuring out these details, and there's a lot of like political things, and then those kind of things just kind of keep going. And that's not where if you're trying to help someone out with machine learning, you can't really help with the internal political stuff. You want to help them do their workflows and their processes properly.
Yeah, I was going to ask if part of it is a semantic thing where, folks will say my model is in production, but it's in production in the sense that it's making predictions that end up in a Excel spreadsheet that someone's manually analyzing versus kind of closing the loop so that a system is reacting to the decisions made by the model.
That's a really good distinction. And so people say we have a bunch of models in production, and we talk about operational machine learning. So I kind of break the machine learning into two buckets: analytical machine learning, which is where it can be offline. Its main purpose is to influence a human-driven decision. So let me score some leads, and then I'll look at the scores, and then maybe I'll send some emails or something like that based on them. And we'll do that on a weekly basis. That's an analytic machine learning type of use case. Operational machine learning is online. It needs to be monitored. It affects the customers directly, drives automated decisions, and it's often real time. And those are the types of use cases where ML is powering your product. Those are the types of use cases where being in production means something very different.
Yeah, yeah. Mike, as always, this has been a wonderful chat. Maybe a place to wrap up is for, folks that are interested in what you've been talking, your approach to data-centric AI, kind of where should they be looking?
Yeah, thanks, Sam. Two places. So, and maybe one update since we last spoke. Tecton is now the main maintainer of the popular open source feature store called Feast. So That's a solution that anybody can try. Very lightweight. It's the kind of build your own feature store framework, and it's certainly the most popular feature store. You can find that at feast.dev. And if there's any listeners from companies who are really trying to figure out, like, hey, how do we build real production applications, ML applications, and we need some help on the data side of things to help this stuff get into production either in real time, super reliably. That's what the Tecton feature platform is for. And so folks can check us out at tecton.ai.
Awesome. Awesome. Well, thanks so much, Mike.
Thank you.